In this chapter, we will be continuing your study of trigonometry. In this lesson, we will take a look at the exact values of the trigonometric ratios of angles that come in all the different quadrants.
All right, hi everybody. So in this lesson here, we're going to take a look at, well, like it says here, exact values in all the quadrants here. So in a previous lesson, we introduced the idea of an angle in standard position, and we started to introduce the basic trig ratios for those angles. And we showed how there was a transition from SOHCAHTOA to a definition more in line with what you would expect to see on the coordinate plane. So definitions in terms of x and y and so on. Now in the previous lesson, we did go beyond the 90-degree mark here, but the primary focus in that first lesson was to talk about what would happen if you're talking about angles in the first quadrant. Well, now let's take a look at what happens if you go and look in different quadrants here. So we'll take that same triangle that we had, we'll flip it over the y-axis, and so now we'll put that triangle that was in the first quadrant, now it's in the second quadrant here. So there's our reference angle. That is the angle inside the triangle. Okay, so there's our rotation angle that we're going to be studying. That's an angle between 90 and 180. Now, notice that when that happens here, the x-coordinate changes from positive x to negative x, and that has to do just with the direction that it's pointing. But because of the way the trig ratios are defined, sine is going to look exactly the same. So the sine of theta is going to be y over r. Now that means that in the first quadrant, when that triangle opened this way, we would have got the sine of that angle being y over r, and the sine now of this angle is going to be y over r as well. We're getting two angles that are going to share the same trig ratio, and you're going to see that's going to be a common theme as we go around the circle, that there's going to, almost always, there's going to be pairs of angles that will share the exact same sine ratio, the exact same cosine ratio, and so on. Here, cosine will be a little different. It'll be negative x over r, just because it's pointing to the left. And tangent will be y over negative x, or negative y over x. And in this case, it's going to be, the theta here is going to be 180 degrees minus that reference angle. Okay? When we move into the third quadrant, where we're between 180 and 270 degrees, okay, all we're doing is flipping that triangle over the x-axis, so now it's in the third quadrant. And it's going to be a similar sort of thing, except now the x and the y distances here, okay, are going to both be negative, just because of where they're pointed. So the point on that terminal arm will be a negative comma, a negative value. But again, trying to be consistent here, sine of theta is going to be negative y over r. Now notice cosine, again, is negative x over r. That particular ratio is going to stay the same. So assuming that angle inside the triangle is the same in both these cases, it's the exact same triangle, the cosine of this angle and the cosine of this angle will be identical. It's kind of an interesting outcome. Tangent will be positive y over x, because when the opposite and the adjacent here are both negative, the negatives will cancel each other out and you get a positive there. And again, to get that rotation angle, it's going to be 180 degrees plus the reference angle. Okay, 180 degrees to get down to the x-axis, and then plus that angle inside the triangle. And then lastly, we're going to look at what happens when we move into the fourth quadrant, and that's going to be an angle between 270 degrees and 360 degrees. Okay, in this case, it's like taking this triangle that we had here and flipping it back over the y-axis. Notice that the y coordinate here is still negative, but x is now positive. So sine will be negative. Sine will be negative y over r. And again, I want you to notice that that's the same as it was in the third quadrant. Okay, so the sine of this angle and the sine of this angle, okay, assuming that this is the same triangle, assuming that's the case, then those are going to be the same ratios, which is, again, it's really neat. Cosine will be positive x over r. Tangent will be negative y over x. And again, to get the theta there that we're trying to study, that's this angle right here, that would be 360 less the angle in the triangle. Okay? Anyway, so those are the relationships that we're getting around the full circle in terms of the relationship between the rotation angle and the reference angle, and then what the sine, cos, and tan for each for the angles in those separate quadrants should look like. So a couple things to remember here, and I know that we've commented on this before, but we're going to comment on it again. This gives us something called the cast rule. Okay, so quadrants 1, 2, 3, 4. Cosine is positive in 4. All of them are positive. All of them give positive ratios in the first quadrant. Sine is the only trig ratio that gives a positive value if the angle is in the second quadrant. Tangent is the only ratio that gives a positive value if the angle is in the third quadrant. Okay? And so another way of looking at it would be like this little bow tie thing. Now what I like about the bow tie thing is it identifies for you where that reference angle is in every case here. Okay, notice the triangles are never drawn to the y-axis. They're always drawn, regardless of where the terminal arm is, they're always drawn to the the x-axis. I was going to say positive x-axis, that's only here, to the negative x-axis here. Okay, gives you a sense of the relationship between x and y and the triangles that we draw when you write it like this. Okay, let's take a look at some examples then. All right, now in this question we read that the point -512 lies on the terminal arm of theta. We want to find the exact values for the other three primary trig ratios, and we're going to find the angle theta to the nearest degree. Okay, well first of all, let's identify where -512 is. -5 is to the left of the origin and 12 is up, so that is going to be somewhere like that. So there's theta, what we're looking for here. We grab that point somewhere on there. We know that's going to be the point -512. Okay, so that means this x-coordinate here is -5. The y value here is going to be 12. Maybe I'll zoom in a little bit on that. Now, to get all of the trig ratios, I need r. Now, I don't need r for tangent, but I will need it for sine and cosine, so let's figure that out. R is going to be the square root of x squared plus y squared. Okay, so in this case, that is going to be the square root of -5 squared. Please make sure that when you do this, you put the -5 in the parentheses there. Okay, if you don't, then you're going to do 5 squared, and you're going to subtract it from the y squared, and you don't want that. You want if x is negative, you want that whole thing squared there. Plus 12 squared, and when we evaluate that, we're going to get 13. Okay, so our r value up here is going to be 13, and that allows us to get the trig ratios as long as you know the definitions. Okay, so the sine of theta will be y over r. So in this case, the y coordinate of that point, okay, and sometimes people, even after we go through this, they get confused as what I mean by y and what I mean by r, x and r here. It's the y coordinate right there. So 12 divided by, and then r is 13. Okay, the cosine of theta, and in this case here, when I'm asking for the trig ratio, I want to know whether it's positive or negative, because that gives me a sense of where it's located here. Okay, -5 over 13, and the tangent here would be y over x here, so 12 over -5, but we don't usually leave the negative there. Normally we'll either move it up to the numerator or put it out front, so it looks something like that. Okay, now I told you before that you're going to see duplication here. Like, this is not the only angle that has a sine of 12 over 13. This is not the only angle that has a cosine of -5 over 13. So how do you know which angle you're referring to? Well, the thing is, sine is giving a positive ratio, cosine is negative, tangent is negative. The only quadrant that could possibly happen in is quadrant 2. So individually, that is not enough for me to know what angle I'm referring to. But when I give you this information right here, or at least I give you some idea what quadrant it's in, then I've narrowed it down. So for example, watch this. When I now try to find out what theta is, I got to bear in mind that there is actually some repetition here. So what I'm actually going to do, the first little bit of math that I'm going to do with my calculator is not going to be to find theta. Actually, what I'm going to do is I'm going to find out what alpha is, what the reference angle is inside the triangle. That's what I want to work on first. Now, if I choose sine, my alpha here will be the inverse sine of 12 over 13. Okay, so we'll go to my calculator. Okay, second sine, 12 divided by 13. And when I press enter, and I'm going to round that again to the nearest degree here, it's going to be 67 degrees. So 67 degrees. Now, that is the angle inside the triangle. Now, again, just to illustrate that we didn't have to use sine, we could have used, let's say, cosine or tangent. If I had chosen cosine, though, I want to warn you here, because the trig ratios can have different signs, those signs mean something and they mean something specific to the calculator as well. And in fact, if you start to include the negatives here, the calculator is programmed to deal with those negatives differently depending on which trig ratio you're working with. So my advice to you is to simplify that, to make that easier here. Identify, when you look at the cosine of theta equaling -5/13, just bear in mind that there are two different places it could be negative, two different places it could be positive. Ignore the fact that it's negative right now. Just use the positive value. In a bit here, we're gonna talk about how we can be a little bit more specific with that negative, okay? But for right now, just ignore the negative. And when we do this, we should end up getting the exact same angle. So let's just take a look here. Second cosine, okay, of 5/13. Assuming that we've done our math right here, that should give us 67.3. There we go again. So again, we're seeing some confirmation here. So our reference angle here is 67 degrees. But that is the angle inside the triangle. That means that this is 67 degrees. To get the rotation angle that I'm interested in, what I got to do is go backwards and think, okay, 67 degrees in quadrant 2. My angle theta here is going to be 180 degrees minus 67 degrees, okay? 180 degrees minus 67 degrees is going to be 113 degrees. Now, just to verify that that's correct, that worked out the way I wanted it to. Oh, actually, you know what? I was going to do this on the calculator and show you something kind of funky on the calculator, but I realized here we had to round that 67, so it's not actually going to work. But one of the things you could have done here is we could have, for example, taken the sine of 113 degrees, and you get 0.92. Now, if we take 12/13, very, very close. Now, not exactly the same. By about the thousandths place here, we tend to diverge a little bit. That's just because a little bit of rounding we did. So right on the money here. If I take the cosine of 113, notice what happens here. We do, in fact, get that negative ratio. That negative pops back up. Anyway, I hope that makes sense. We're going to do a bunch more examples, and hopefully the more times you see this pattern happen, the easier it'll get. All right, now in this question, we read that it's the point -2, -6, and that lies in the terminal arm of theta, and we want to figure out, again, the three primary trig ratios, and then find the angle. Okay, so -2, -6. So from the origin, -2, -6, we're down here in the third quadrant. So it's this angle is the one that we're looking for here. And then based on what I'm seeing there, I know that this is going to be -2 and this is going to be -6. So the x length here along the x-axis will be -2, -6. And now I got to figure out what r is. If I want to figure out what the trig ratios are, I'm missing r. So r is going to be x squared plus y squared, square rooted. And then x is -2, and again, please make sure you put parentheses around the -2 and the -6 there, so that when you take the square root, you're taking the square root of the right thing. -2 squared is 4. -6 squared is going to be 36. So this is the square root of 40. And now think about that. One of the things you're probably going to have to do here is to simplify down that root 40. At least I'd be a little shocked if you didn't. Root 40, let's go over here. 40 is going to be the same as 2 times 2 times 2 times 5, right? 4 times 10. There's a pair of 2's there that I can pull out, and that's it. That's the only pair. So then you're going to be left with 2 root 10. So root 40 will be the same as 2 times the square root of 10. Okay, so there's our r value there, 2 root 10. So now we can give the three trig ratios here. The sine of theta will equal the y coordinate, -6 over 2 root 10. Now, first things first, bear in mind we've got this -6 over the 2. Okay, I can simplify that. Be -3 over root 10. The root 10 is still in the denominator. That may be as far as you're expected to go, but I doubt it. I doubt it in a lot of cases. I suspect you're going to be expected to what we call rationalize that. We want to get rid of the irrational number in the denominator. So to get rid of the root 10 down there, I multiply numerator and denominator by root 10. Now in the numerator, the best I can do here is just simply state that that's -3 times root 10. I don't know what that's going to be, but that's what I got to do. But in the denominator, root 10 multiplied by the square root of 10 would be the square root of 100, which is 10. And so there we go. Cosine is going to be the x-coordinate over the r, so -2 over 2 root 10. In this case, it's a little clearer. The 2's will cancel. That's quite nice. Now, they won't cancel with the 10. I know you might be tempted to think, well, there's a 2 that I can cancel with a 10 here, but that's not 10. Bear in mind, that's the square root of 10. That's a different number altogether. So you got to kind of leave that on its own. And that, again, that might be good enough, but it might not be. So this might end up having to be -√10 divided by 10. Whoops, sorry, you can't see that. Wow, all that rationalizing, you didn't see it. -1 over root 10 multiplied numerator and denominator by root 10, and that's what you're going to get. And then finally we get the tangent. Now the nice thing about the tangent here is there's no radical in that because it's just going to be the y-coordinate over the x-coordinate, so -6 divided by -2, and the answer there is 3. Okay, so now I'm going to figure out what the angle is. But bear in mind, I'm not going to be able to go directly to figuring out what theta is. I'm going to have to figure out what the angle inside the triangle is first. I got to figure out what alpha is. Okay? Now it doesn't matter which trig ratio I use. Okay? Doesn't matter which one I use. I just got to pick one, but I'm going to find alpha first here. So I tell you what, just for argument's sake here, let's use sine. Now I have a bit of an ulterior motive to this. Okay? Let's use sine. So sine of theta is equal to -3 root 10 over 10. Okay, so I knew that the sine of theta was -3 root 10 over 10. So when I use that information to figure out what the angle is inside the triangle, I am going to do the inverse sine of, but in this case I'm not going to use the negative. Okay, bear in mind what I said before. The calculator understands the negatives to be slightly different depending on which function you're using, but it treats sine, cos, and tan essentially the same if you're using a positive value. So let's use 3 root 10 over 10. Positive 3 root 10 over 10. Okay, so now go to my calculator here. This will be the inverse sine of 3 root 10 divided by 10. And if you run into difficulties, if you're not getting the same answer I get, you might want to check to make sure that you either close the parentheses around the root 10 here, or you got out from underneath the radical by pressing the right arrow. Okay, and when I round that, I'm going to get 72 degrees. Okay, 72 degrees. Now, that is the angle inside the triangle. Now, to get the angle in the third quadrant, okay, which is really what I'm interested in, to get that rotation angle, I got to take that 180 degrees and then add that angle that's inside that triangle. So now 180 plus 72 is going to be 252 degrees. That's the angle that we're looking for. All right, next question. Similar to the previous one, just that the information that we're given here is a little different. I am going to give you one of the trig ratios. I'm also going to tell you what quadrant we're in. Now, we know we're in quadrant 3, so I can come down here and draw this out. Okay, so I'll draw my triangle. Now, I'm also told that the cosine of theta is equal to -3 over 4. Okay, but cosine of an angle is going to be the x-coordinate over r. So just by making a direct comparison here, it looks to me like the x value here is going to be -3, which makes sense. It's consistent because I'm going to the left. And then r is 4, would look something like that. Now I'm supposed to, in this question here, find the other two trig ratios and then determine the angle. Well, to get the other two trig ratios, I need to know what y is. Okay? R is the square root of x squared plus y squared. So in this case, I know 4 is going to equal the square root of -3 squared plus y squared. Okay, well, to get into this radical here, I got to get rid of the square root. So I'm going to square both sides. That'll get me 16 is equal to, and now -3 squared will be 9 plus y squared. Okay, I'm going to subtract the 9 from both sides, and that will get me 7 is equal to y squared. Now, with a question like this, when I take the square root of both sides, I got to pay attention to the fact that I was squaring some number to get 7. So the answer here could either be the positive or the negative square root of 7. I don't know which one it is. But in this case, because I do have a diagram, or I have an indication of what quadrant we're in, I do know what it is. I know it's not positive root 7 because the triangle is oriented so that the y-coordinate points down here. This actually has to be, so therefore, that's what these dots mean, this has got to be negative root 7 is my y-coordinate. Just because of where this is located. So this is going to be negative root 7 is equal to my y. Okay, now I can do my sine. Whoops, I want you to be able to see that when I write this. The sine of theta is going to equal negative root 7 over 4, okay, y over r, and not my cosine, you already know my cosine. It's the tangent that we're missing. The tangent of theta is going to be y over x, so negative root 7 over negative 3. And then we know that the two negatives will cancel each other out. Okay, now I got to figure out what the angle is, what the rotation angle is from here all the way over into here. But to do that, the very first thing that I'm going to do is figure out what the angle inside the triangle is. And I keep saying that because I hope that's going to click with you, and you'll be thinking about that when you answer a question like this. So you got to figure out what that is first. I've got 3 trig ratios I could use. Yeah, but because I'm the one that figured these ones out, and I'm a little nervous that I might have made a mistake there, let's go back and use the original one, the cosine of negative 3 over 4. So just like I did before, I'm going to use the opposite trig function here, so the inverse cosine, but I'm not going to worry about the negative. I'm just going to use the value of the ratio, because what I'm really looking for is just the size of the angle. The negatives are going to give me an indication of position in terms of quadrants. The value here is going to give me a size, okay, how big the angle is. So we go second cosine to get the inverse cosine, 3 divided by 4. Okay, and so we're looking at an angle of roughly 41 degrees. So our reference angle is 41 degrees, but now we got to put that in the right quadrant. We got to put that into the third quadrant. And to get into the third quadrant, I go 180 degrees first, and then I get to my triangle. So that theta, that rotation angle, is going to be 180 degrees, and then we're going to add to it that additional 41 degrees for the triangle, and that is going to get me 221 degrees. Okay, hope that makes sense. All right, this next question, very similar to the previous one, but we're tweaking it just a little bit here. So now I'm telling you that the sine of theta is equal to negative 3 over 5. Now bear in mind, sine is related to the y-coordinate and to the r value. Now r is always positive. So let's think about this. Sine is negative. That's where the y-coordinate is negative. Now the y-coordinate is negative in quadrants 3 and 4. Well, that's not enough information to tell me which one specifically I'm in. I don't know. I could have sine being negative 3/5 here or negative 3/5 here. That's possible for both. I need a little bit of extra information, and here it is. Cosine is greater than 0. Cosine is positive. Okay, well, cosine is related to the x-coordinate. Okay, and r, but r is always positive, so it's really just the x-coordinate that could cause an issue here. So this is telling me that the x-coordinate has to be positive. Well, that occurs in quadrants 1 and 4. So let's think about it like this. Sine is negative in quadrants 3 and 4. Cosine is positive in 1 and 4. Okay, well, when I cover up these things that don't work, the only option I'm left with is quadrant 4. This angle must be down here. That's basically the cast rule. Cosine is positive, sine is negative. There we are. There's our theta that we're looking for. Now, we've already gone through and mentioned that we know that sine is y, whoops, sorry, not y over x, that is in fact tangent. Y over r. So that's going to get me negative 3, negative because it's pointing down. And then the r value is going to be 5, and so I'm missing x. So just like we did in the last case here, we got to figure out what that is. That's going to be x squared plus y squared square rooted. That's going to be 5 is equal to the square root of x squared, don't know what that is, but negative 3 squared. To get what x is, I'm going to square both sides, so that means 5 squared is 25, and then squaring the right-hand side is just going to get rid of the radical. Negative 3 squared will be 9. Okay, now I'm going to subtract that 9 from both sides there, and I'm going to be left with x squared is going to equal 16. And x could be positive or negative 4 when I take the square root of both sides. Now, positive or negative because when I square something, whether that's positive or a negative, either case is going to give me a positive 16. So I don't know which one I meant there. However, because of the way this graph has to look, that x value there must be positive 4. It's got to be 4 because it's pointed to the right. I am in either quadrant 1 or quadrant 4, and x is always positive there. Okay, so now, based on that triangle, I can tell you that the cosine of theta will equal 4 over 5 x over r, and the tangent of theta will be y over x. Good. Now, once again, I've got to figure out what the angle is. So the very first thing I'm going to do is I'm going to figure out what the reference angle is inside the triangle. And because I did a little bit of work to get cosine and tangent, I'm not going to use that. I'm going to use sine. I'm going to let sine help me out here. So my alpha here, my reference angle, is going to be the inverse sine of, now again, the negative here is going to tell me what quadrant to look in, or at least it helps me figure out what quadrant to look in here. But when I'm trying to figure out the size of the angle here, I don't want the negative. I only want the numeric value. So here, this is going to be the inverse sine of 3 over 5. Okay. Now I'm going to yank out the calculator here. So second sine of 3 divided by 5. All right, and when I round that to the nearest degree, I'm going to get an angle of 37 degrees. Good. Now, I still got to put that in the proper quadrant though. So now notice that if I were to wrap all the way around, that would be 360, but I'm less that angle. So it'd be 360 degrees less that reference angle. So the rotation angle I want is going to be 360 minus 37 degrees. Okay? And 337, I was going to say. 360 minus 37 is going to be 323 degrees. And so that's the angle that we're looking for in this question. Okay, now this next question here is a question, I just love this question. I love questions that work like this. This is designed to kind of help you practice your algebraic skills, okay? The point -4b lies on the terminal arm of theta. What is the exact value of cosine? Okay? Now, in order to figure out the exact value of cosine, bear in mind that cosine of theta is going to equal x over r. Well, I already know that x in this case is going to be -4. What I don't know is r. But I'm also not given a couple other bits of information. I'm told the y-coordinate is b, but I don't know if that's positive b or negative b. And I don't know what b is. Okay? So am I talking about this angle here, or am I talking about this angle here? Now it turns out when I try to solve this problem, it's actually not going to matter which one of those I intended, okay, because I'm going to deal with them both in turn. But what I got to do here is I got to kind of press forward. A lot of times I'll have students that'll look at this and say, well, I'm not given enough information that can't answer this question. You can't get a specific numeric answer, but I can get an algebraic answer. In other words, I can write an answer that preserves the structure of the answer without giving me the specific value that you might kind of in your heart that you want. So, for example, let's just say, for instance, right now that what I meant was the second quadrant angle. Just to start us off here. Now that's going to change in just a second here, but anyway, let's just say that that's what I'm looking for. I know that my x coordinate here is -4. My y value here is going to be b. Now, to get cosine, I need r. R is found by taking the square root of x squared plus y squared. Well, okay, x squared, that's the easy one because I know the value was -4 squared. But here, this is where somebody might get a little bit frustrated with this. But you just, like I said, you just got to press forward here. Well, what is y here? What is the y coordinate in this question? And the answer is it's b. That's what I'm given, b. So where it was y squared here is now going to be b squared. So r is going to be the square root of Well, negative 4 squared is going to be 16, and then plus b squared. Now, I can't go any further forward than this. That's it. Because I can't take the square root of both of those, because there is that implied set of brackets here. Anytime you've got that radical symbol, it implies that whatever's underneath that bar is inside a set of parentheses. Now, I hope that has been made clear to you in the past. That's the way that works here. Order of operation tells us we have to do what's inside the parentheses first, which means I would need to square the b and add the 16 before I can take the square root. But because I don't know what the b is, I don't know how to square it. I don't know how to add it to the 16. That is the dead end. I cannot go any further than that. That is as simple as I can make that. That's my r. Which means, therefore, that the cosine of theta, the cosine of the angle that I'm looking for here, is going to be negative 4 over the square root of 16 plus b squared. Now, some of you are not going to like that as an answer. I actually have no problems with it. That's fine. That's a great answer. It gives me the structure of the answer. As soon as I know what b is, I would square it, add it to 16, take the square root, and then keep going here. So I know what I have to do without being able to specifically do it. Now, but just to kind of honor the fact that some of you are going to have teachers that are going to insist on this, and again, it depends on the order that you're doing the course in. We might have to rationalize this, meaning that I might have to multiply top and bottom here by 16, the square root, I should say, of 16 plus b squared. In the numerator, the best I can do is simply write out negative 4 times the root of 16 plus b squared. And then the denominator would become 16 plus b squared. The radical would go away. Now, before someone asks, can I cancel the 4 and the 16? The answer is no, you cannot. Because again, this bar here implies a set of brackets around the numerator and the denominator. And so before I could do that division, I would have to do the addition that's down here. And because I can't, because these are unlike terms, I can't add those, which means I can't move forward and then divide. This is a dead end. That's as far as we can go.
For the next couple minutes here, we're going to take a look at a special set of angles called the quadrantal angles.
Okay, just now for the next few minutes, we're going to talk about something called quadrantal angles. Okay, and these are angles where the terminal arm, maybe I should zoom out here a little bit, where the terminal arm of the angle is on one of the axes. And so we're actually looking at a very specific set of angles. It's either going to be 0 degrees, 90, 180, 270, or 360. Just that group of them. Okay, we're only looking at those angles there. Now, if we stick to the definitions that we've set up, okay, then there's actually a very natural way of getting the sine, cosine, tan for those particular angles. Okay, so remember, we're going to stick to the fact that r is going to be the square root of x squared plus y squared. Okay? Now, if that's the case, then when you're talking about an angle, let's say, for example, that's on the y-axis, so either 90 degrees or 270, notice that the x-coordinate is going to be 0 in those cases. Okay? Basically, we're talking about y-intercepts. The x-coordinate is 0. So in that particular case right here, if you're looking for r and you let y go to 0, well, 0 squared is just 0 plus x squared is x squared. The square root of x squared is x. So r becomes the same thing as x. Similarly, if you're picking a point that's on the x-axis, the y-coordinate goes to 0. And if we're looking for r, okay, you get the x goes to 0, 0 squared is 0, plus y squared is y squared, square root is y. Now what that does is give us a situation that looks like this. So if we're talking about the cosine of 90 degrees, okay, bearing in mind that this is on the y-axis here, though r is equal to y, cosine is going to be x over r. So 0 over y, cosine of 90 is therefore 0. Sine is going to be y over r, but the r coordinate is y, so y over y is 1. Sine of 90 is 1. Tangent is going to be y over x, and in this case the x coordinate is 0. Okay, so y over 0, well, just think about that. Anything divided by 0 is undefined. And actually, if you go to your calculator and verify and look at those right now, cosine of 90 you'll see is 0, sine of 90 is 1, tangent of 90 you're going to get an error. It's undefined. We are sticking really, really strictly to the definitions. Okay, cos is x over r, y over x. It's just that in this particular case, at 90 degrees, r and y would be identical. Just like over here at 180 degrees, r and x are identical. And now look at the value here. You're getting negative x comma 0. That's the point right there. So the cosine of 180 would be negative x over x. The x's cancel. You're going to get negative 1. Okay, that's because, again, the r value is the same as x. Sine would be y over r. So in this case, it would be 0 over r, or x in this case. Sine of 180 is 0. Tangent of 180 would be y over x, and in this case, y is 0. So 0 over x, 0. Okay. Now, that being said, there is another way that we can remember this. Actually, I'll draw this off in the corner here before I refer to this diagram. There is another way of doing this. What we could do, okay, because we're going around the circle here, we're letting r be kind of a constant here. Because that works for any values x and y, one of the things we can do here is we can get kind of lazy. With this particular topic here, we can kind of get lazy here. Let's let r equal 1. If it can be anything anyway, we'll just let it equal 1 here. Now if we do that, the coordinates here become 1 comma 0. The coordinate here becomes 0 comma 1. That's because, remember, our radius is just going to be 1 here. R is 1. So I reach out 1, I reach up 1. Here, this is going to be negative 1 comma 0. And down here, this would be the point 0 comma negative 1. Now, if you bear in mind that the sine of theta is y over r, cosine of theta is x over r, and actually we're going to just stick with those two right now. Okay, and because tangent of theta being y over x actually doesn't help us here. In this particular case here, if r is equal to 1, then y divided by 1 is just y. X over 1 is just going to be x. Okay, and so what happens here is the sine of the angle becomes the y coordinate, the cosine of the angle becomes the x coordinate. Now that's only true when the radius is equal to 1, and we call that the unit circle. Okay, because the number 1 is called the unit. And so we're just describing this in terms of that radius there, the radius of 1 circle. So sine is the y coordinate, cosine is the x coordinate. That's kind of awesome, because now think about it like this. What's the cosine of 0 degrees? 1. It's the x coordinate. What's the sine of 0 degrees? 0. That's the y coordinate. Cosine of 90 is 0. Sine of 90 is 1. Cosine of 180 is negative 1. Sine of 180 is 0. Cosine of 270 is 0. Sine of 270 is negative 1. If you want tangent, just remember that it's the y coordinate over the x coordinate. So tangent of 0 would be 0 over 1, 0. Tangent of 90 would be 1 over 0, which is undefined. Tangent of 180 would be 0 over negative 1, 0. Tangent of 270 would be negative 1 over 0, undefined. Okay? And so now this little chart, this little chart right here kind of gives you a way of remembering all that. But I really, really think if you just remembered the radius is equal to 1, okay, r is equal to 1, you have to know the definitions of sine, cosine, tan in terms of x, y, and r anyway. This just makes a very, very easy way of remembering all that. Okay? So I hope that makes sense here. We're just trying to give you a shortcut here for remembering the sine, cosine, tan of the quadrantal angles. Now, these are significant because most of the angles, most of the trig ratios that we saw when we went around the circle, they got repeated. Like you'd have two places where sine is, let's say, 3/5, two places where cosine is 4/5 or whatever. But with a couple of the quadrantal angles, they are the only ones that show up with those particular values. And you want to be just aware of how you get those. All right, so let's find the exact values of these quadrantal angles. So the sine of 270, okay, sine is related to the y-coordinate. 270 would be down here, and the coordinate of that point would be negative 1. So the sine of 270 would be negative 1. Cosine is related to the x-coordinate. 180 would be over here. The coordinates of that point would be negative 1, 0. So cosine of 180 would be negative 1. Tangent of 90 is right here. On this unit circle, this would be 0, 1. Tangent is going to be the y-coordinate divided by the x-coordinate. So 1 divided by 0 is undefined. Sine of 360. Sine is related to the y-coordinate. Oops, sorry, I did that backwards here. Is related to the y-coordinate. And the y-coordinate at 360, when we're talking about the unit circle, is going to be 0. Cosine of 270. Cosine is related to the x-coordinate, 270. The x-coordinate is 0. Sine of 0. That's related to the y-coordinate. And 0 degrees and 360 are basically the same thing, both pointed in the same direction. It's going to be the exact same value. So sine of 0 would be equal to 0. Okay, now finally, if theta passes through the point 0, -6, find the exact value of the three trig ratios. Okay, 0, -6. That's going to stay on the y-axis down here at -6. So I can tell you right now that essentially this is going to be theta here, okay, is going to be 270 degrees. That I can tell just by looking at it. And I've already gone through what the sine, cos, and tan are for 270 degrees. Now, but I tell you what, let's approach this the way that we're supposed to here. This is going to be the point 0, -6. If I want to figure out what the other trig ratios are, what I need is to figure out what r is. And so that's going to be x squared plus y squared. That's going to be 0 plus 36, or 36, and r is just going to be 6 when I take the square root of that. Okay? Now, I didn't need to do it like this. I could have chosen the unit circle like we did before. But I don't want you to assume that it's always got to be the unit circle. I can approach this with however big the circles that's given to me. I can respond to that. Just a unit circle is just a convenient little way of simplifying the work here. But I could work with a circle. It's got a radius of 6, not a problem. Okay, so I know that r is equal to 6. I can come back up to this right here. R is equal to 6. So the sine of theta is going to be the y-coordinate divided by r. -6 divided by 6 is -1. The sine of 270 is -1. Now, at this point here, I'm kind of pretending I don't know that it's 270, even though I do. So sine of theta is equal to -1. Cosine of theta, x-coordinate is 0. R value is 6. 0 over 6 is 0. And again, I knew that that was true because I knew that the cosine of 270 was 0. And finally, the tangent. Tangent is going to be the y-coordinate over the x-coordinate. And -6 divided by 0 is undefined. It's not equal to 0, it's undefined. Okay? 0 divided by 6 is 0, but -6 divided by 0, that's undefined. Check that on your calculator, you'll get an error. Okay? Hope that makes sense.